All right, so this is part two. I will have to upgrade my Screencastify. I can only do 5 minutes at a time right now, but maybe that's all we need to do, 5 minutes at a time. So we left off at empirical formula. So we said empirical formula is the simplest whole number ratio of the elements in a compound. Comparing that to molecular formula, which molecular formula is the actual number of atoms in a compound. So it's the molecular mass, and we find that molecular mass by adding up the mass of all of the elements and atoms in that particular compound. So C6H12O6. That is a molecular formula. So there's actually 6 carbons, 12 hydrogens, and 6 oxygens. Whereas for empirical formula, that's the simplest whole number ratio, which that would be, which we wouldn't actually put the ones there. That would be CH2O. Okay. All right, moving on. Percent composition. So when we talk about percent composition, remember we're going to take the total molar mass, total molecular mass of that particular compound, and we're going to divide that into the mass of each element that's in that particular compound. So you can see a sample problem here. There we go. All right, so we have KMnO4, which has a molar mass of 158 grams. Remember, we get that just by adding the atomic mass of the potassium, the manganese, and 4 oxygens. That's where those numbers came from. And you can see that down here. And then, so to find the percent composition, we're going to take the mass of the potassium and divide it by 158, and that gives us a percent, 24.7%. Remember, this is based on the law of definite proportions, which says that the ratio of the mass of constituent elements in any pure sample is always going to be the same. So potassium permanganate, KMnO4, is always KMnO4. It's always going to be 24% potassium, 34%, 0.8% manganese, and 40.5% oxygen. Okay, so definite proportions says the ratio of the mass of the elements in any pure sample is always the same. Compounds can be molecules or formulas. So they're formula units. There are two ways of saying the same thing. So a compound is a molecule, and molecules are usually made up of nonmetals that are covalently bonded. Or we can, if it's ionically bonded, we don't call that a molecule, we call it a formula unit. Both of them are compounds. So some examples, I'll use sugar again. I've been teaching biology for a little while, so sugar is a good example. C6H12O6 is sugar molecule. That is a molecular compound. It's a molecule because those are non-polar bonds there. Non-metals. Ionic would be salt, NaCl. That is an ionic bond, and so we would call that a formula unit. We wouldn't call it a molecule of salt. Okay? All right, moving along. Here are empirical formulas, and this is just how we determine the empirical formula, how we determine the smallest whole number ratio. First, we need the percent composition. So what we're going to do is, remember, we are always going to go the percent to the mass to the mole, and then divide the smallest number of moles into all the other moles that are there. Okay, so for example, calcium hydroxide, we have 13.5 grams of calcium divided by the atomic or the mass to mole ratio. So 13.5 grams of calcium. I know that in 1 mole of calcium, there's 40.1 grams. And so that gives me 3.37 moles of calcium. I do the same for my oxygen. 10.8 grams of oxygen. There's my mass to moles for oxygen, which gives me 6.75 moles of oxygen. And then hydrogen, do the same thing, gives me 0.668 moles of hydrogen. I take all three of those mole numbers and I divide them by the smallest number of moles, which is 0.33.